In this video, we are going to learn about something really awesome. Let's take an iron rod, a copper coil of wire and a power supply. Set up the entire circuit like this. Now remember, there are two types of power supplies possible, DC and AC. Let's start with DC first. Now, when we switch on the power supply, current starts flowing through the coil, and as we have seen earlier, it starts behaving like a solenoid. We have also seen how a solenoid is actually very similar to a bar magnet with, suppose, its north pole here and south pole here. Also, since this is an iron rod, even this gets magnetized because of the magnetic field lines. Now, let's switch the power supply to an AC source. As we know, in an AC source, the current directions keep changing, which means the direction of the magnetic field in a solenoid will also continuously change. That is, the north and the south pole keep alternating according to the direction of current. Also, because of this, the magnetic field in the iron rod will also keep changing. Okay, let's switch off the power supply now. Take an aluminium ring and place it on the iron rod. Remember, the power supply currently is AC. When you switch on the supply, you'll notice that the ring all of a sudden jumps and may even leave the rod. But assuming that the power supply was on for some time, and if you leave the ring on the rod now, you will notice that it starts balancing itself in mid-air. Wow, right? This here means that there is some force acting in the upward direction on the ring, which is balancing its weight. You see, what's happening here is that somehow there is a current that starts flowing through the ring. And the direction of the current, if measured through a galvanometer, will show you that it is in opposite direction to the current in the solenoid. If the solenoid current is clockwise, then it will be anti-clockwise in the ring and other way around. Now, suppose current in the solenoid is clockwise. Therefore, according to the right hand thumb rule, it will have a south pole here and a north pole here. Similarly, since current direction is anti-clockwise in the ring, according to the right hand thumb rule, there will be a magnetic field to the center of the ring in this direction, and thus its south pole will be here and north pole here. Thus, there will now be a repulsive force on the ring as both these south poles face each other, and this repulsive force is what balances the weight of the ring. And guess what? Since this is an AC source, the north and south poles of the solenoid keep alternating, which means the poles on the ring keep alternating as well, which also means that the current direction in the ring is also alternating. Now, how this current all of a sudden starts in the ring is something that Faraday will explain through its Faraday's law of electromagnetic induction, which you can see in another video. All I can probably tell now is that this has something to do with flux, or rather change in flux. See, with an AC power supply, since the magnitude and direction of the current continuously change, the magnitude and direction of the magnetic field in the solenoid also keeps changing. This means that the flux through the ring also keeps continuously changing. This change in flux causes an EMF in the ring, and thus a current starts flowing. This finally leads to the repulsive force. This entire process through which EMF was set up in the ring because of another magnetic field is what we call electromagnetic induction. If you were using a DC power supply, the flux through the ring would have been constant as the magnetic field is always constant. Thus, there is no repulsive force and the ring does not move. You will understand this more clearly once you learn Faraday's law. So friends, in this video we discussed about electromagnetic induction and how it is caused by a continuous change in flux. Till next time, happy learning!